Hi class. In this video, I'm going to be talking about perfect squares and non-perfect squares with respect to repeated multiplication. But before I do that, I just want to review a concept that I talked about before. So in a previous video, I mentioned that perfect squares are integers that can be expressed as the product of two identical integers, with product meaning multiply. So what that means is if I took 4, which is an integer, and I multiplied it by itself, I get 16, which is also an integer. That means that 16 is going to be a perfect square. However, now I have a new definition for a perfect square. So a perfect square now can be a rational number that can be expressed as the product of two identical rational numbers. So product still means multiply. What that means is if I took 4, which is an integer, but it's also a rational number, and I multiply it by itself, I get 16, which is a integer but also a rational number, and that will be my perfect square. Now, the reason I redefine perfect squares as rational numbers is because now that we learned about rational numbers, I can show you in the next couple of videos that perfect squares can actually be in fraction form and decimal form as well. Okay, now let's move on to non-perfect squares. A non-perfect square are numbers that cannot be expressed as the product of two identical rational numbers. So before I talk more about this, I just want to recall what square roots are with you guys. So the square root of a number is a value that when multiplied by itself gives the original number. And this is the symbol we use for it. The square root of a perfect square results in a rational number. So let's say 36, we know that's a perfect square because 6 times 6 equals to 36. If I take the square root of 36, I'm just going to get the answer of 6. How I got that answer is you just have to think what number multiplies by itself to get 36, and that number happens to be 6. Hence, the answer to the square root of 36 is just going to be 6. Now, what happens when we take the square root of a non-perfect square? So I know that 30 is going to be a non-perfect square because I can't think of two rational numbers that can multiply together to get 30. So here's what I do know though. I know that if I took the square root of 25, I'm going to get 5 because 5 times 5 is 25. And I already know that if I take the square root of 36, I'm going to get 6 because 6 times 6 is 36. Now, the square root of 30 is between 5 and 6. So with that, I can sort of estimate that there's a number that exists between 5 and 6, where if I multiply it by itself, I should be able to get the square root of 30. It's just that number is not a rational number, so it's not going to be a very nice number. But what I can say is that the square root of 30 is going to be approximately 5.5. Now, if you want to know how I got that estimate so quickly, there is a previous video that I made on how to estimate the value of a square root of a number that is a non-perfect square. Now, moving back to the original question at hand, for repeated multiplication with respect to perfect and non-perfect squares, okay, looking at this example here, 4 times 4, that's repeated multiplication. It gets me 4 squared. This little 2, which is my exponent, just tells me how many times I multiply 4 by itself. And then I get this perfect square, which is 16 here. Now, do recall the square root of 16. That equals to 4 because the square root of 16 is what number can multiply by itself to get 16. In that case, 4 times 4 is 16. Hence, the answer to the square root of 16 is going to be equal to 4. Now, I'm going to do a bit of substitution here. If the square root of 16 equals to 4, instead of writing 4 times 4, I'm going to write the square root of 16 times the square root of 16. And if 4 times 4 is 16, and the square root of 16 equals to 4, wouldn't the square root of 16 times the square root of 16 also equal to 16? Do we notice a pattern here? If you take the square root of a number and you times it by the square root of the same number, you just get that number without the square root. Okay, that's good. And there's also one part I want to talk about. Here it says 4 squared, right? So what I can do instead of that too is if I take the square root of 16 and then I square it, I was going to put brackets here for convenience, and then I square it, that also just gets me the 16. So when you see a number in this form where you have the square root of a number times the square root of the same number, you just get that number inside the square root, and the square root disappears. Similarly, if I have the square root of a number and I square that square root of a number, I just get the number inside of the square root. Okay, now this helps us to answer the non-perfect square problem. Let's say I want to find a number that can multiply by itself to get to 30. And now I can figure it out. So recall, if I take the square root of 30 and I multiply it by the square root of 30, technically now I just get the square root of 30 squared, and then I eventually just get the answer inside of my square root, which is 30. So as a repeated multiplication, what is a number that can multiply by itself to get to the answer of 30? It would be the square root of 30 times the square root of 30. And these would be exact values, because before I told you that the square root of 30 is approximately 5.5, but that's just an approximation, right? So here, this is the exact value, which we talked about in a previous video, where I have the square root of 30 times the square root of 30. That gets me exactly 30. But if I were to find an estimate, then I would do 5.5 times 5.5. And I would assume that gets me approximately 30. But that's an approximation. That's the approximate value, right? So approximate value versus exact value. Might as well review that here while I'm at it. So hopefully that helps you understand how the repeated multiplication can help you find the exact answer for 30. So now if someone asks you what two numbers can multiply together to get 30, you can just say the square root of 30 times the square root of 30 gets you 30.